7.4, number 28, pretty tough problem. You've got a cubic that has an absolute value in it, and it says find the length of the non-smooth curve. Alright, so if it was just x cubed plus 5x, it would just be a cubic and there wouldn't be any issue. But since there's an absolute value here, we have two options for this. Absolute value of x means that it could be x for x greater than 0, but absolute value is negative x for x less than 0. So whatever makes this 0 is kind of the point where it bounces off the x-axis. So that's at 0. So if it's greater than 0, it's just x. If it's less than 0, that would be negative x. So this function y becomes x cubed plus 5x as long as x is greater than 0. But if x is less than 0, it's going to be x cubed plus 5 times negative x, so minus 5x. So we turned it into a piecewise function. And 0 does land in our interval. So what we need to do is from negative 2 to 0, we're going to use this one because that's before 0. So less than 0, we have to use this one. So it's x cubed minus 5x. Oh, we're doing arc length, not area. So it'd be the integral. Sorry. Integral from negative 2 to 0 of the square root of 1 plus that derivative squared dx. So that derivative would be 3x squared minus 5. So that'll give the arc from negative 2 to 0, and whatever you get there, we're going to add to an additional integral, an additional arc from 0 to 1. So we went from negative 2 to 0, now we're going to go from 0 to 1. So from 0 to 1, we'll use this equation, or that expression, so it's the square root of 1 plus that derivative squared, so 3x squared plus 5 squared dx. So that'll give you the first couple, this will give you the last chunk. I think I would just plug them into the calculator and combine the two, and you'd have the total arc length. I think it's 7.05 plus 6.08. Total we get 13.13 for the arc length.